Everybody. This is going to be Wednesday's video. We're going over 5.2. This is naming ionic compounds. I'm going to skip the do now that I have here because this is going to be a longer video, and I kind of apologize for that in advance. But out of the videos that I've been doing, there's just a lot of stuff to cover in 5.2. So bear with me here. It's going to be a little bit lengthy, and it may be something, because there's enough content in here, that you want to go back and look at or rewind a few times. So some things that we've already gone over, but you've got here are two types of ions, right? We've got cations and we've got anions. And so when we're naming them, don't worry so much about the cations, the positive charged ions. Okay, the name changes a lot. There's not really a rule to memorize. For anions, they're going to have a suffix, meaning that the word always ends in "ide." So chlorine atoms will turn into chloride ions. So whenever you refer to the ion for an anion, it's going to be "ide." Sulfur turns into sulfide, right? Or bromine turns into bromide. They always end in "ide." So think about this, right? With a compound that we already know and that we were working with yesterday, table salt. What's the name of table salt? If you're thinking of sodium chloride, right? Sodium is our cation, and then we have our anion, chlorine, which changes to chloride ions. So we have a sodium ion and a chloride ion that combine to make sodium chloride. Is this going to switch? All right. So the ordering of the two does matter. So it seems a little obvious, right? But which one is correct? Sodium chloride or chloride sodium? Right? We always say sodium chloride. We're never saying chloride sodium. The order is always going to be the metal comes first and then the non-metal comes second. Or if you're thinking about the charges, sodium chloride, right? The cation, the positive charge, comes first, which is a metal, and the anion, the negative charge, chloride, comes second. So sodium chloride, right? Or calcium +2, bromide -1. Aluminum +3, oxide -2. Metal first, then non-metal. The formula name, when we write it out, is only the element symbols. So sodium chloride is just going to be smushed together sodium and chlorine symbol. So Na and then Cl. And remember to keep the C capitalized because it's chlorine. Or calcium oxide, right? Capital Ca, lowercase a here for calcium, and then capital O for oxygen, and you just smash them together. Okay, so there's no space in between here. So NaCl, sodium chloride, CaO, calcium oxide. Now, I don't know, where my drawing capabilities went here. I think I have to switch over out of this mode of the presentation. That was kind of weird. Okay, so I'm going to switch over here because I want to draw for these ones, I think. So we're going to start here. Come on. Lithium bromide, right? And what are the formula name for lithium bromide? Now, I'm going to take an extra step here that I think will be helpful in a minute. It's probably not going to be helpful now, but I think it will be helpful in a minute. Okay, so what I'm going to do is I'm actually going to write out lithium, right? And lithium, since these are all ions, I'm going to put the charge here. So Li plus, and then Br minus. Okay, just to remind myself. Now, if we are making a compound, the compound has to be neutral. So we need a ratio between lithium and bromine, or the bromide ion here, excuse me, that makes this a neutral compound. So 1 lithium, 1 bromide, right? 1 positive, 1 negative, cancels out to a net 0. So we just need 1 of each for right now. But we're going to see in a few minutes here that it gets a little more complicated. So the formula name should be like this: lithium bromide, okay? LiBr. All right, let's skip over to the next one here, and you're going to have to give me a sec because my drawing tool takes a minute. All right, I think we're ready to move on here. Magnesium sulfide. Again, try this out on your own. What's the formula name? So the formula name will be the element symbols. All right, again, I'm going to do something that I think will have payoffs in a minute here. So we've got magnesium. What's the charge on magnesium as an ion? Yeah, 2 plus, right? It loses 2 electrons when it ionizes. And then what's the charge on sulfur after it ionizes and becomes sulfide? Yeah, it's a 2 minus, right? Because it gains 2 electrons for the nearest noble gas. Okay, again, we want a neutral compound. 2 positive plus 2 negative, that's a net 0. So these two work together. So we have M lowercase g S, MgS, magnesium sulfide. It's just the element symbols written out. I'm going to move on and do one more. Okay, last one here. Calcium chloride. Now think about this for a sec. When you're writing out the formula name, and I want you to try it right now, what's the charge on calcium? And what's the charge on the chloride ion? Now I'm not going to write on this slide because I reference it on the next slide. So I'm going to skip. You should have CaCl for your formula name, right? But the charges don't work out nicely, right? If we write out CaCl, calcium is a 2 plus. And chlorine is just a 1 minus. So we need to find a way to balance these two. Again, we need a neutral charge, right? A net 0. So if we have 2 positive charges, then we end up needing 2 negative charges. So what we do is we include 2 of the chloride ion, right? If we have 2 single negative charges, that's equal to the 2 positive charges that calcium has. So when we write it out, and maybe I can do a better job of writing it out here. We have CaCl2 would be the formula for this compound, because calcium by itself is 2+, and a single chloride by itself is a 1-. So we need 2 1- to equal the 2+. We're going to try another one of these right here with charges that don't really play nice, right? Where they don't neutralize each other right away. So what's the formula for aluminum chloride? And go look up how aluminum would ionize. Go look up how chlorine would ionize into chloride. What's the charge on each one? So we have Al, and this is actually 3+. And the chloride, right, is 1-. So how do we get these two things to neutralize each other? Well, and I'm going to put the charges underneath here. We've got 1-. Think about it kind of like in terms of multiplication, right? We need 3 of these -1 charges to equal the +3 charge from 1 aluminum. So we need 3 chlorides here. So overall, this is our formula, right? AlCl3. Because we're saying we need 3 chloride ions for every 1 aluminum in order for it to be a neutral charge. We're going to practice one more here. All right, try now aluminum oxide for me. Formula name for aluminum oxide. Remember to write out your charges first. I think that will help you out. All right, I'm gonna go in here. I think I'll do the formula in red. So we know we have aluminum, right? And we know we have oxygen, or the oxide ions. Now, if we come down to the charges here, we just said that aluminum was 3+, right? What's oxygen? Yeah, oxygen is 2-. Okay, this one's a little bit trickier than the previous two even, because we can't just, multiply the 2- by a certain amount to equal 3+, but we need a set number of the same charges. So we need a like multiple between these two. So we have 3, we have 2 here, and And it may not seem obvious right now, but the common multiple, right, between these two things is going to end up being 6. So if you have 2 aluminums, you have 2 3+ charges, how many total positive charges would you have? You'd have 6, right? And if you have 3 2 negative charges, then you have 6 negative charges. And then the 6 positive charges cancel out the 6 negative charges. So what we need to put up here is the math that we did down here. So we said that 2 aluminums and 3 oxides, right? Coming from here, coming from here. So 2 aluminum makes a total 6 positive. 3 oxide makes a total of 6 negative, and those two things neutralize each other. So we have Al2O3. Now, if this is a little bit confusing, you can go back, okay, rewatch from the beginning here. I've also got a link that I'm going to show you in the homework, so you can look at your homework right now, and there's a link at the bottom of the page, and there's a site there that may help you figure this out. But if you are kind of stuck here, either email me or figure it out with friends, or with that site, but don't move on from here yet, because we're going to take it another step, and I don't want you getting confused taking that next step. So this is what you need to be comfortable with before you move on. Just a warning for you. So we've got one last thing before we take that next step, which is just doing these in reverse. And when you have the formula, then you just need to provide the written names, like the full written out names of the elements. So I think this is generally easier for people, and we can try it out right now. Take a second, pause the video if you want. What's the written name of all 5 of these? All right, so you should have potassium, right, K, bromide. Remember the "ide" suffix at the end of every anion. If you were listing out these names, that might have been the one thing that tripped you up there, is you might have put bromine. It's going to be bromide when we write out the name in the formula. So potassium bromide. Second one, sodium sulfide. The numbers don't matter. It doesn't change the name here. Sodium sulfide. Third here, potassium phosphide. Remember that "ide" suffix. Fourth one, lithium Li chloride, lithium chloride. And the fifth one, NaI, sodium iodide. Now, you might have noticed that we've been incorporating some different elements, right? Potassium, sodium, lithium, bromine, sulfur, chlorine, iodine, phosphorus, but we're missing a good section of the periodic table when we're doing this. And we're not counting the transition metals because they don't have a single set charge. Right? They have those multiple sets of valence electrons. So this is the part where if you didn't get the charges on the static cations and anions, I need you to practice that before you move on to this. And I need you to have that down. So if we have uncertain charges, things get a little more interesting, right? Copper can be Cu2+, or it can be Cu4+. But here's the thing, when we're doing chemistry with them, they behave differently depending on whether it's Cu2 plus or Cu4 plus. They have different properties depending on how many electrons that they have. So when we're writing out labels, right, when we're writing out names, scientists need to know which kind of copper do we have. How do we know which copper is in our copper chloride? Well, we depend on the charge of the anion to tell us, right, how many of the anions are in there. And we write the charge of the cation, right, copper, in Roman numerals. So if that's a little bit fuzzy, let me draw it out here. Let's start off with this one, copper 2 chloride, CuCl2. Now, I would ask you here, right, what's the charge on copper? But you'd be like, Mr. Brester, I don't know. It could be either 2 plus or 4 plus, and you're totally correct. So we're going to ignore copper, for just a minute, and we're going to focus on the chlorine. So chloride is an ion. Yeah, that was a little messy, sorry. Chloride is an ion, has what charge? Just a single chloride ion. Yeah, that's a -1, right? A -1. So if we have 2 of them, right, Cl2, how many total negative charges do we have? Yeah, we're going to end up with 2 negative charges on the chloride, right? Total. So, in order to balance that, how many charges do we need on the copper? Well, 2 minus, right, getting to 0 would be 2 plus. So then here's what happens. To note that copper is 2 plus here, we put it in Roman numerals in parentheses on the inside of that. So we say copper 2 chloride. Copper has a 2 positive charge. Keep that in mind here as I go to the second one. Okay, I'm going to do the exact same thing here. Copper again, I would ask you, right, what's the charge? And you'd be like, Mr. Brester, I don't know. It could be 2 or 4. Totally fine. We write out the chloride, right? And this is 4 chlorides, Cl4 here. What's the charge on chloride? You'd be like, 1 minus. I got this. So if we have 4 of them total, how many negative charges do we have in the compound? 4 times the -1 gives us 4 negative charges. Now, we have only 1 copper, right? So those 4 negative charges are balanced by what? 4 positive charges. And guess what? We write copper 4 because we're saying that the copper has 4 positive charges. So it would be here 4 plus to go against the 4 1 minus charges and make it a net 0, right? 4 positive is equal to 4 negative, and they neutralize each other. If you're not familiar with Roman numerals, I've written them out here in the blue. So 1 is I, 2 is double I, 3 is triple I, 4 is IV, and 5 is V. And those go in parentheses right after you would list out the anion. So it'd be like copper 3, whatever. Okay, but it goes right after the cation. Sorry, I think I said anion first. It goes right after the cation, right after the metal. Okay, we're going to try this, team. Let me make sure this is still recording here. Yeah, like I said, it's a little bit longer. I know we hit 25 minutes. Bear with me here. I'm going to try 3 more of these. All right, FEO. What's the written name? So when you're doing this, I would give you tips here. And actually, I'll run through this first one. Here's what I would do. I would say, oh, I know I have iron. Right? And I want to write out the symbol here, because I'm trying to figure out what charge we have, right? I know this is a transition metal, so I know we need our parentheses. And then I know that we have oxygen as well, because we have oxygen. Okay, so this is Fe and O. What's the charge on oxide as an ion? Right, that is, and I'm going to write this in a different color here, 2-. So FeO, written here, this is just a 1-to-1 ratio. So I'm going to actually put these closer to each other, right, because we know it's just 1-to-1. So it's FeO. The O is 2-. What does the charge on iron have to be in order to cancel out the 2-? Yep, has to be 2+. So iron, since it is 2+ here, we write that the iron has a positive charge of 2, and we put that in our Roman numerals. So this would be iron 2, oxygen. Bad. What's the suffix that Mr. Brester forgot? Yeah, it's oxide, right? Silly Mr. Brester. So iron 2 oxide. Good. All right, I got 2 that I want you to practice on your own here, and I'll run through them after you've done them. Let's see, what's next? CrO2. All right, try this out, team. Okay, I know for a start, right? We've got Cr, we've got O2. That means that we have chromium. And I know this is a metal, so I'm going to put in my parentheses, and that we have oxide as an ion. All right, we just need to figure out the charges now. What's the charge on a single oxygen? On a single oxide ion, it's 2-, but we have 2 of them, so the overall charge is 4-, right? 2 -2 charges leads to 4-. Okay, we have 1 chromium atom here, 1 chromium cation. What has to be the charge overall? Well, to cancel out the 4-, right, it has to be 4+. So this would be chromium IV, chromium 4 oxide. One more for you here. SR2, S3. All right, here's what I want you to do. I want you to go through this, take your time, think about it carefully. This one's a little bit trickier than the previous two, but if you could do those previous two, you can do this one as well. Written name, right? We have SR2, S3. So that is strontium, we know. It's a transition metal, so we need a parentheses. And then sulfide, right? We know we have sulfur in there. Okay. Let's figure this out here. Do we know the charge on strontium? No, it's a transition metal. Do we know the charge on sulfide ions? Yes, we do. What's the charge on a single sulfide ion? Uh-oh, I meant to change colors there. Come on, program. All right, 2 minus, right? The problem is we have 3 of them. So 3 times 2 minus gives us what total negative charge? Yeah, 6 minus here, right? In order to neutralize that, we need a total positive charge of 6 plus. Net 0, right, between these two. Drawing a little equal sign there. Now, here's something that we haven't come across before. This is SR2. So we have 6 positive charges distributed across 2 strontium ions. What's the charge on just 1 strontium ion? You can do some quick math here. 6 divided by the 2 strontium ions that we have, right? 6 total positive charges divided by 2 strontium ions means that our individual strontium by themselves are 3 plus, right? And if you think about this, it just means we have 3 plus on each times 2 is 6 plus, which is equal to the 6 negative charges that we have, which is 3 times 2 negative. So it all works out, okay? You can double check yourself. This means that the strontium is what charge? We're going to write strontium 3 because we have, what's the color that I haven't done? Let's do pink. Strontium 3 plus, right here, right? Strontium 3. It refers to the individual strontium atoms. Individual strontium ions. Ugh. Okay, that's all that I've got for you for slides. I want to take a quick look at your homework here to show you as you go down. Okay, I'm going to ask you to refresh on the charges of ions, and then you'll go through naming. This on the bottom here, this is the site that I'm talking about for practice and to teach you a little bit. What you'll do is you'll pick one of the elements that's on the left side. So let's say I wanted sodium. We are going to bond it now ionically with an element on the right side of the periodic table, right? A metal plus a non-metal. So sodium has 1 valence electron. Let's pick something else with 7 that's going to get -1. Okay, so it's going to ask you what type of bond is this combination likely to form. Please stick with ionic bonds. Okay, so pick something from the left side of the periodic table first. So it's going to be ionic bonds. Now, based on your knowledge of each of these, predict the number of atoms of each atom needed. And, right, this shouldn't say atom. We know better. We're combining ions, right? We're not combining atoms. Okay, what I'm going to do here, Sodium chloride, right? Sodium is +1, chloride is -1. How many of each do we need? We need 1 of each, right? 1 positive plus 1 negative, that's a net 0. So if I go back here, and let's see if it kept our choices. No, it reloaded the page. Okay, sodium, chloride. Come on. Ionic bond, right? And we need 1 of each. 1 positive, 1 negative, done. So then it shows you up here them combining, and it says correct, right? 1 positive, shown here as an ion, 1 negative, and then it, oh, will it actually show you the ions going through? Oh, no. And then it gives you the name, right? The symbol here, the formula name, and then the written name, sodium chloride. So I think this is a helpful tool. If you work through some practice with this, it can help you out a little bit. Unfortunately, it doesn't do transition metals, which are a little bit more challenging, but it gets the base point across, and you can practice later with the other transition metals. All right, that's it for the video, and I hope that you have a great Wednesday.